This is a video on performing a regression analysis using the LibreText Regression Analysis Calculator. And in this problem, X is the independent variable. That is the number of minutes a woman spends on the phone a day. And Y is the dependent variable. That is the woman's weight. And we want to know if there's a linear correlation between those two. So let's find the correlation coefficient, null and alternative hypotheses, so on and so forth. Before I do any of that, let's just bring up the calculator and put in these numbers. So we're going to go to regression analysis, which is almost at the bottom. And this is what that page looks like when you go there. And you're just going to scroll down. And you need to enter the X values and the Y values separately with commas. So I'm going to do a copy and paste. And now I have my copy and paste done. All my numbers are in there. I just have to put commas between each number. And I can just do that by hand. Okay, and now click on plot points. And we can see we've got our points plotted and we've got the line of best fit plotted. It looks like there is a moderate positive correlation between number of minutes spent on the phone and pounds. Let's go down to the information here. The first thing we're asked for is the correlation coefficient R, and that's to 2 decimals. So to 2 decimals, that would be 0.87. I'll record that over here, 0.87. The null and alternative hypotheses are there is either no correlation, that's rho equals 0, where rho is the population correlation coefficient, or there is one, in which case rho is not equal to 0. And that's the alternative hypothesis. And so when we compute our p-value, and let me come back over here to the calculator, we want to make sure that this top line is checked because we're doing a two-tailed test. Either rho is 0 or it's not. And here we get the p-value, which to 4 decimals is 0.0023. Now we want to use a level of significance of 0.05 to come to a conclusion on whether or not there is a statistically significant linear correlation. So in this case, we've got our value, our p-value, which is 0.0023, and that is certainly less than our significance level, 0.05. So that means we reject the null hypothesis. If p is low, then null must go. And so that means the alternative hypothesis states rho is not equal to 0. That means there is a correlation. Statistically significant evidence to conclude that there is a correlation between the time a woman spends on the phone and their weight. Okay, down to r squared. Sometimes that's called the coefficient of determination. R squared, we're also given, it's 0.7562. But I was asked only for 2 decimals, so to 2 decimals, that's 0.76. And what does that mean? You've got a drop-down menu, and what it means is there's a large variation in women's weights, but if you look only at a woman with a fixed weight, this variation on average is reduced by 76%, because that's the percentage form of 0.76. I like to say it differently. I like to say 76% of the total variation can be explained by the linear regression line, and the rest of it can't. Okay, moving on, the regression line. So we want this to 2 decimals. So this is going to be y equals 107.28 plus 0.70 times x. Okay, so that's the line of best fit for the data points. use the model to predict the weight of a woman who spends 54 minutes on the phone. So we use our regression equation, which is here, and we put 54 minutes in for X. So we get Y equals 107.28 plus 0.7 times 54 minutes. And when we do that, we get 145.08, but they want us to, I believe, okay, they want us to round to the nearest whole number, so 145 pounds. All right, on to the next one. These numbers obviously aren't exactly accurate. 1, 2, 1, 2. I had trouble with the numbering. Interpret the slope of the regression line in the context of the question. So remember, X is the number of minutes a woman spends on the phone. So for every additional minute, you're going to pick up 0.7 additional pounds. And finally, interpret the y-intercept in the context of the equation. Well, the y-intercept is when x equals 0. So the y-intercept is 107.28 plus 0. So just 107.28. And so we would say the best prediction for the weight of a woman who does not spend any time on the phone is about 107 pounds. I hope this is helpful.